So I think my screen is visible to you.
Yeah, visible, sir.
That? Yeah, that's good. Hello.
Yeah, hello, sir.
Yeah, okay. 1 second, please. 1 second. So show bad network. That's I'm waiting.
Yeah, Lokesh sir. Yeah, good evening everyone. We'll start session within few minutes.
Yes. Yeah. So good evening, guys. So I have taken so much because of my system problem. So I will start very. One second. Yes. Yes. So welcome back. So in the yesterday class, we've seen about something like as a data conversions. Seen about three data conversion from packed BC to ASCII, ASCII to packed BCD, decimal conversions. So these are the very simple thing. So what we are going to be doing is, so we will make as a unpacked BCD, then we are going to be converting into the ASCII and we are going to be displaying into the P1 and P2 and making unpacked BCD by using the masking, adding with the going to be given as a ASCII. Okay, so that's how we're going to be doing the program. So this is a simple program. Next, after that, we've seen about the ASCII to BCD. So packet BCD. So if you are ASCII number, how we can able to convert into the BCD, packet BCD. So we have seen that one. So for example, let us take first we are going to be taking the and and displaying the results. So that's how we are going to be doing the conversion. So that's how the conversions are used. Next, so we have seen about we have seen about how we can able to use delay using the timers. So this is a very important thing. So in the previous classes, we have seen that by using the for loop, we can able to create the delay. So but the for loop is going to be giving not accurate delays. Okay. So because of 1275, so we have seen that one how we can able to calculate and all those things. Because of that one, accurate delay. So in order to get the accurate delay, what we require is we require the timers. So we have seen about the timer. So in that one we have seen about the T mod register. So where the T mod register is a 8-bit register. So it's going to be having a timer 0 and timer 1. So in the timer 0 and timer 1 we are having a M1 and M0 which will decide the mode. So depending upon the 00, 01, 10, 1. So mode 0, mode 1, mode 2, mode 3. So mode 0 is nothing but, so we are having a 30 timer. So mode 1 is nothing but 16-bit timer and mode 2 is nothing but it will be 8-bit auto reload timer. And if M1 and M0 both, then there's a mode 3, so which can be placed as a split timer. Okay, like that we are having seen that one. So, and we have seen about how the block diagram is going to be having. So, in the block diagram, we have an oscillator. So, after that, we are having a data to counter. So, which will be utilizing because one mission cycle is equal to 12 clock cycle. So, divided by 12. So, there we are having a two signals. One is called as a C bar, C slash T bar. If it is T is selected, then it's going to be acting as a timer. If we are going to be selecting as a C, it will be act as a counter. And we are having a TR, and after that, we are having a TH and TL. So with the higher and lower bits, and we are having an overflow flag. So whenever it reaches to the from 00 to FFH, so it will, after FFH, it will be overflowed. So then it's going to be given to the 8051 microcontroller so that whatever the code you have given is over. Like that, it's going to be giving an one interrupt. So this is about the total working of the timers, and we have seen about the how to write the delay. So in the first program, we have seen timer 0 is a 16-bit mode and generate a delay. So the delay so is going to be having any delay. So that's why. So here we have taken as a wide delay. So in this one T mod is nothing but which mode we are going to be operating, and we have taken as a TH naught and TL naught as a 00 I mean 3500H. So and we have taken like this. So this is how the void delay program is going to be executed, and we can able to see. So in order to find out, so the one more important thing is, so how much count is required in this one is nothing but, so count is equal to whatever the count we required, like 50 milliseconds or 10 milliseconds or 2 milliseconds, 1 millisecond, like that, divided by 1.085 microseconds, which will give the number. So we need to subtract that one from the final count, then we can able to get your count. That count is going to be converted into hexadecimal. So then that must be loaded into the TH and TL register. So then we can able to get the whatever delay we require. So that delay we can able to get. So that's how the delay calculations are going to be happening. So we have seen another program to generate the switch with the 500 edges and 750 edges. So depending upon the switch position, so we are going to be generating the 500 edges and 650 edges. So here, so 500 edges is nothing but f is equal, frequency is equal to 500 edge, t is equal to 1 by 500. So then time. So according to the time, so we know the count. Count is going to be given as a whatever the required time divided by 1.0685 microseconds. That will give the value. So we need to subtract the final value to this value, and a value is going to be given. So that value we need to convert into the hexadecimal. That must be loaded into the TH and TL. So that's how we are going to be having. So in this one, so we have seen the 0F and FC and 67 one, FD and 98 one. So like that. So I think you have calculated that one. Okay, next we can able to see this. So we write a 8051C program to toggle only P1.5 continuously for 250 milliseconds. So 250 milliseconds. So for the 250 milliseconds, so we are going to be having something like this. Okay. So this how we have seen about in the yesterday class. Today class, so we will try to discuss about this program. First, we will discuss about this program. Write an 8051C program to toggle only P 1.5. So I think we have completed this one. Next. So this is the only problem. Okay. So try to analyze this problem. Write an 8051C program to create a frequency 2500 Hz and pin number 2.7. Use timer 1 mode 2 to create the delay. Instead of timer 0, here I am going to utilizing the timer 1. So then what we require to give is, in the T mode, we need to go with the timer 1 value. So that is something bad. So in the timer 1, we are having a 0, 0. So with the mode 2, that's why 1, 0. So that is something bad. The value we are going to be having is 2, 0. T mod is equal to 0x20. So that's how we are having a timer 1 mode 2. How much we require to take the delay? We require to take the frequency of 2500. So we know that time period is equal to 1 by 2500, which will be given as a 400 microseconds. So we need to make both the on and off equally. So that's why T on and T off values are going to be taken as a 200 microseconds. So what the count? We are going to be having a count as a 184. So as it is going to be working in the mode 2. So mode 2 is nothing but 8-bit auto reload. So that's why the initial count is going to be taken as a 256 minus 184, which is going to be given as a 72. So 72 in terms of the hexadecimal, which is going to be given as a 48H. Okay. So please go through these are calculations we are going to be having, and try to load the T naught H. So here in the delay program, this one. So T mod is equal to 0x20 to 0x20. T H naught and TL naught is going as, so TH naught higher value for 48H and TL naught is equal to 0. Don't want to give anyone. TR naught is equal to 1, while TF is equal to 0, 0. TR naught is equal to 0. Clear this one, TR naught and TF naught. So this will give the delay of 200 microseconds. One is going to be given as a 200 microseconds. On time is a 200 microseconds. Off time is equal to 200 microseconds, which is going to be given as totally 400 microseconds. Okay. So that's how there is some difference in the program. So please try to write the program, this program. Write a program. So this, try yourself. So I will post the answer for this one in the tomorrow in the next class. Okay. Okay, write a problem, write a program. So you need to write the program. I have given the data, total data to you. Okay, so write a program to create the frequency of the 2500 Hz on the pin 2.7. Use the timer 1 mode 2 to create the delay. Okay, try to write this program. Next thing, what we are going for is, so we are going for the another concept which is called as a counters. So the counter is nothing but to count the external event, whatever the counts we are going to be having to count the external events. So that's the use of the counter. So how it is going to be doing? Let us take an example. So let us take, I'm having an example. So we are going into the one big mall. Okay. So at the entrance of the mall, we are having one sensor. So the sensor is molded to the entrance of the mall. So this sensor will give the pulse, some frequency pulse, if any man enters into this mall. If anyone enters into the mall, then this sensor will give a pulse. There frequency, it's going to be giving a pulses. Okay. For every entry, it will give one pulse. So if one man and one human enters, so it will give one pulse. If two human will give another one pulse. So this is called as a event happens. So event happening is nothing but a human is going to be entering into the mall. That's a human generated. So if you able to count this pulse, if you able to count these pulses, then we can able to know how many members are inside a mall. How many members are inside a mall, we can able to know. So that is the purpose of the counter. Where these counters are available. So these counters are available in the T mod register itself. T mod register itself, we are having a T mod register. So in the T mod register, we are having a counters also. If you see the T mod register, so there the third bit. So if you take the T mod register D0, D1, D2, the third bit D2 bit, there we are having a C bar, C slash T bar. If you make this as a 1, if you make as a 1, so then it will work as a counter. Okay. We will try to program the counter. How the real is in the context. So here we are going to be conventional device. Okay. From one, so going to be giving this one. So these are the things we are having here. So timer can also be used as a counter, counting the real events happening in the real. So we can it is an external pulse that increments the TH and TL register. So previously in the timers we have taken the oscillator, crystal oscillator, but the TH and TL. So but here we are using the external pulses. T mod and TH and TL register are used as a timer programming except for the frequency. So here we are having the difference between the timer program and the counter program is, so in the timer program we are using the crystal oscillator, internal crystal oscillator, whereas in the counter program, okay, so not internal frequency. T and T bar in T mode register. So here you can able to see the C and T bar bit in the T mode register decide the source of the clock for the timer. When slash T is equal to 1, the timer used as a counter and gets from outside. The counter counts up as the pulses are fed from the pins. It's 450. So okay, you can see here. So the 40 is called the port 3.5. So externally, if your microcontroller 805 microcontroller, and if you can able to locate the pin number 14 and 15, so we are going to be connecting the sensor output to this 14 and 15. What are these 15 pins are? The 14 and 15 pins are P3.4 and P3.5, which is going to be internally take as a T0 and T1. Okay. So timer counter, external input, timer counter input from the external. So we are going to be giving this one. So this is how the block diagram will look like. So timer with external mode 1, so mode 2. Okay. So here you can able to see here. So from external things, the pulses are going to be generated. That is going to be given to the gate. So this is going to be called as a gate. So from the TR, the TH and TL will start counting. So whenever the TH and TL goes to the FFH, FFF, so then it will be overflow. The TF flag became as a 1. So in the overflow, all these things. But so here we are not using the overflow. Instead, we are going to be utilizing the TH and TL. So in our example, to count the number of persons inside a mall, so we are going to be taking the TH and TL. So in the TH and TL, we can able to know the count, how many persons are entered in the. Okay, so like that. So here this is going to be enter into the mode 2. So in the mode 2, it's going to be reloaded. So 8-bit counter with reload. Okay. So this is a 16-bit counter. So this is the 8-bit counter with the reloader. Okay. So whatever the count we are going to be having, again we are going to be reloading into this one, and we are going to be starting again. So on those purposes, we will go with the mode 2. So later we will see the examples how we can able to use the mode 1 and mode 2. So as of now, try to understand that. So mode 1 is a 16-bit counter. We can able to count the persons, number of persons from 0 to 65536. And in the mode 2, we can able to count the 0 to 256. So this is the auto reload actually. So we will see that one, how the mode 2 is going to be work. So here is an example, how we can able to write a program. Here is an example. See, so assuming that clock pulses are fed from fed into the pin T1, write a program for the counter 1 in mode 2 to count the pulses and display state of TL1 count on P2, which connect to the 8 LEDs. Okay, so as the program is something like this. So assuming I'm having a 8051 microcontroller, I'm taking the input from the T1. So is nothing but was the pin we are having, the T1 is nothing but P3.5. P3.5. Okay, from P3.5, there is nothing of 15th pin. So we are taking the pulses. So these are continuously pulses. So that is the thing that in this example, so I am connecting the the source of the clock to the 15th pin. Next, use as the counter one. Use the counter one in mode 2. So mode 2 is nothing but auto reload mode. 8-bit counter with the auto reload. Auto reload. Next, count the pulses and display TL1, count on the port P2. So I am having a port P2. So in the port P2, I have connected the 8 LEDs P2.0 to P2.7. I have connected the 8 LEDs. So I need to tell the state of that. This is P3.5. How many pulses it's going to be? I haven't counted, something like that. Okay, next. See here. So first, so what we are going to be having is move. So here we have written the assembly level program. So later we will see about the C program. First, try to understand this one, because in the assembly level program we can easily understand. So what happening inside the program. So that's why first we will go with the assembly level program. Then we will go to the C program. The first instruction, move tmod comma 01100B. So what is the meaning of that one is, so we are using the counter that too, it's going to be in the mode 2, and we are making the C/T is equal to 1. So you know the tmod register. So in the tmod register is the 8-bit register. It's going to be having a M0, M1, C/T bar gate, M0, M1/T bar gate. So we need to use the timer 1. So whenever we are using the timer 1, so we are going to be having a upper nibble. So that's why that's the count. Next step, we are taking the move th1 comma 0. So first we are clearing the th1, because the th1 is going to be utilizing as a auto reload 8-bit mode. So that's fine. Next step, set bit of P3.5. So because we need to make the P3.5, which is going to be connected to the T1. Okay, that's why we are going to be setting that one, and we are making as an input. Next, set bit TR1, start the counter. So because whenever the TR is equal to 1, the count will be started. So next, move A comma TR TL1. So copy to the move accumulator. Next, move P2 comma A. So display on the port. So up to what? Jump on back up to TF is equal to 0. So you keep doing about that one. So move A comma TL1, move P2 comma A. Is keep doing up to the point where the TF became, when the TF became 0, whenever it overflows. So it is going to be counted up to 256. So from 0 to 256 it will count. So after 256 it will be so the point is going to be continuously moving the data, and is going to be displaying to the P2. Next, clear TR1 and clear TR1. As they've shot them again, it like this. Continuously it is going to be doing like this. Okay, so this is about how we can able to write a assembly level program. So far, okay, program we will try to do one more thing, one more concept. As that the clock is 3.5 port 15. So I'm having T1, so 50. So I'm so the pulse frequency is going to happen. So 0.5 edge on, 0.5 edge off. Okay, T is equal to 1, 0.5, 0.5. You can able to say. Next, Write a C program for counter one in mode 2 to count up and display the state of TL1, count on P1, start the count at 0H. So the same thing. So we are going to be doing the same thing in the C program. How we can able to see? So please look at this program. Look at this program. So to understand this one. So try to this program. So I will explain. So what the use of this program is, so I'm connecting external clock with the pin number 15. That's the P 3.5. I need to count in which counter 1, mode 2. Mode 2 is nothing but 8-bit mode. And I need to display on the P1, port 1. I need to display on the port 1. Same thing. So previously we have taken as a port 2 in the previous example. And here we are going to be taking the port. I need to display the state in the port 1. Okay. See here. First, hash include reg51.h. So this is the header file which is going to be converted into the software functions. Next, S bit, single bit. So we need to take it as a T1, a variable. So which is going to be represented with the P3.5 because P3.5 is pin T1. So that is nothing but 15th pin. Okay. Next, this is the main program. So first, what I am going to making is I am going to making as a T1 as a 1. Okay. Next, T mod is equal to 0x60. We know for the 0x60 is, so we need to make as a T mod. So we work in the counter 1 and mode 2. So that's why the value is going to be given as a 0x60. Okay. Next, TH1. So we are creating this one 0 while 1. TR1 is equal to 1. TR1 is equal to 1. Next, we are sending the P1 to the TL1. So the TL is going to be started and we started to count. So up to 1 is equal to continuously if TF T1 take it the TR1 is equal to up to the 1 will do while this one. Do while do this one. It comes out and it's going to be that is continuously shows the count. How much count we are going to be continuously shows. In the port 1. In the port 1. Okay, this is how the program will work. Okay. So next, we will go for the another program. Yes, assume that 1Hz clock is being fed to the pin T0 instead of T1. Here the program is going to be given to the T0. So which is the P3.4, the pin number 14. Okay, write a C counter 0 1 instead of counter 1 mode 2. Here I am using the counter 0 1 16-bit counter to count the pulses and display the state of TH0 and TL0 register to P1. So this is a simple program. So this is a simple program. This is the extension of previous program. If you can use previous program, it's very easy. The counter 1 program, we work as a counter 0 mode 1. So this is nothing but 16-bit counter. We need to display this is the 16-bit counter. That's why display on P2 T1. We display to TL0 will be displayed on the P1. So the same program. So what we need is first the same thing. First, T mod must be in 0x0. Previous program T1 is equal to 0x60. Here we are having a T1 is equal to 0x0. Why? So we need to go to the T-mod register. So in the T-mod register, we are having a M0, M1, C bar, C/T bar gate. Same thing will repeat here for the timer 0 values and timer 1 also. M0, M1, C/T bar and gate. So we need to go for the timer 0. In the timer 0, it need to work as a mode 1. So that's why. So we will write as a 0, 1, mode 1. So counter is nothing but C bus need to write as a 1, 0, like this. So then it will become as a 5. So remaining are the 0, 0x, 0, 5. So that's the T mod value which we need to load. Make as a TL0 and TH0, TL0 and as a 0. Clear the TL0 and TH0. So because we need to start with the 0, count must be started with the 0. So while 1, 0 is equal, TR0 is equal to 1, start the count, TR0 is equal to 0, TR0 is equal to 1, the meaning of that one is start the count. Now, so display the counted value to the P port 1 and port 2. TL0 must be given to the port 1 and TH0 will be displayed to the port 2. So this one. So up to what time? So up to what instance? Up to the overflow flag is 0. Okay. So up to that one, it's going to be doing this one. Okay. So after that one, we are going to be clearing. TR0 is equal to 0, EF0 is equal to 0. So like this. It will do continuously. Okay. It will do continuously. So we see the output of this program. What it will show? It will show starting with the 0, 0, 0, 0, 4 zeros to F, 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 H. Okay, in the port P1 and P2. The port P1 and P2. So that's how the programs are going to be having. So we will go for another thing. So which is going to be called as a 8051 memory types. What are the memory types we are going to be having? So we already seen about the memory types. So there we are having a EEPROM, ROM, and all those things. Okay. So here, so that here we are having a separate data segment for the data segment and code segment memory. So the registers are related to the data, interrupt service data, stack data, and any frequently accessed data are kept on a on-chip internal memory. So whatever the on-chip internal memory we are going to be having, so on that one, so this type of data is going to be going to be stated. But if we are having a code and large data structures, such as the array and lookup tables, so those are going to be kept into the EEPROM or extended RAM off-chip memory. So we are having two memories on-chip and off-chip. The accessing of the on-chip memory is very fast, but it is a limited. So if you need to store the more data, so like tables and arrays and all those things. So then we are going for the off-chip memory. So that's going to be called as a RAM off. Okay, like that. So 8051 C allows the program to decide which memory segment to assign the data. So the user can have a to assign the data values, whether I need to put it into the internal memory or whether I need to put the data into the external memory. So this thing can Yeah. So hello. Hello.
Yes, sir.
Yeah. Am I audible?
So your voice is breaking, sir. Your voice is breaking, sir.
I'll try to connect one more time.
Okay, sir.
Yeah. Hello. Okay, now, Suresh?
Yeah. No, okay, sir.
Okay. Okay.
Okay.
So these are memory types in 805 we are having. So one is going to be called as the on-chip memory. Second one is going to be called as the off-chip memory. So in the on-chip memory, we are storing something like as related data, interrupt service routine, stack data, and whatever the frequently accessed data we are going to be having, all those going to be stored into the on-chip. But if need to store the large memory exercise, then we will go for the external off-chip memory. So here, so the user can be decide to tell that which data is to be on chip and which data items could be put to the off chip. So the on chip memory is somewhat faster, but it's a more expensive. Whereas the external RAM is going to be having a somewhat cheaper. We can able to have the more. Okay, so on chip RAM is going to be having a 256 bytes, maximum of 256 bytes. So in our version, we are going to be having only 128 bytes only. So whereas the off chip, we can able to go up to
So once again,
64
share your
kilobytes of
screen,
the.
sir. Sir, sorry for disturbance, sir. Once again, share your
Okay,
screen,
okay.
sir.
I'm sharing. I'm sharing. Now is it okay? Hello.
Yeah, 1 minute, sir. Your screen not visible, sir. I think network issues is there.
So I will try one more time. See my screen?
No, sir. Yours, actually network problem there, sir. So that's why we did not get the any
Yeah, I will try to.
sharing screen, sir.
Now I'm able to see my screen. Hello, Suresh.
No, no, sir. No, sir.
So then what will do?
Yeah, okay, sir. Today we'll close the session, sir, because of time also over.
What I can do?